Hello and welcome to the AI Research Roundup. I'm Alex and today is May 13th, 2025. We are looking at a research paper titled Seed1.5-VL Technical Report, which appeared on Hugging Face's trending list just 2 days ago, published on May 11th. This paper introduces Seed1.5-VL, a new vision language foundation model. It is designed for broad multimodal understanding and reasoning, using a vision encoder and a special kind of LLM called a mixture of experts, or MOE. A mixture of experts model cleverly activates only specific parts of its network for each task, making it efficient. The research highlights strong performance, especially in agent-centric tasks and multimodal reasoning. Alright, so this first figure gives us a look at the architecture of Seed 1.5-VL. It shows how the model handles various inputs like text, images of different sizes and aspect ratios, and even video. For video, it uses a clever technique called dynamic frame resolution sampling, which means it can adjust how it looks at video frames, and it adds special timestamp tokens to understand the timing. The core parts are the Seed1.5-VL, which is a vision encoder that extracts features from images and videos at their original resolution, an MLP adapter, which helps convert these visual features into a format the LLM can understand. And then the LLM itself processes all these combined inputs. This setup aims to preserve maximum image detail. Okay, so building on how the model architecture processes various inputs, Figure 2 here gives us a glimpse into the specialized training data they used. We see examples like an image with text highlighted by polygons in part A, a synthesized chart with associated questions in B and D, and a distorted document in C. This extensive use of synthesized data, especially for tasks like optical character recognition, or OCR, which is teaching the AI to read text from images, and for visual grounding, which means connecting words to image regions, is key to the model's ability to understand and reason across so many different types of multimodal information. So after seeing the kinds of data used, this table then details the specific training setup and hyperparameters across 3 pre-training stages. It shows things like the training budget, measured in tokens, which are small units of data like parts of words or image patches, increasing massively. We also see the sequence length, or how much information the model processes at once, grows. Initially, only the MLP adapter is trained, but later all components are fine-tuned with carefully adjusted learning rates, which control how quickly the model learns. This methodical, multi-stage process is vital for its strong performance. Okay, moving on from the pre-training stages, this next figure illustrates the post-training process. It shows an iterative approach combining supervised fine-tuning, or SFT, which is using labeled examples to further refine the model, and then reinforcement learning, or RL, where the model learns from feedback. They use hard prompts, challenging inputs, to push the model. Interestingly, the reinforcement learning focuses on the final output, not the intermediate reasoning steps, using a learned reward model and rule-based verifiers to guide this learning. This sophisticated post-training is crucial for enhancing its problem-solving and reasoning. Alright, so after all that training and refinement, this table presents the benchmark results. Benchmarks are standardized tests used to evaluate and compare the performance of AI models. We can see Seed 1.5-VL in both its thinking and non-thinking modes, stacked up against several other prominent models across diverse capabilities like multimodal reasoning, visual question answering, and document understanding. The numbers here really underscore the model's strong performance, often achieving leading scores, which supports the claim of its state-of-the-art capabilities across a wide range of tasks. Building on those general benchmark successes, this table zooms in on performance in tasks involving graphical user interfaces, or GUIs, which are basically the visual elements like icons, buttons, and menus we use to interact with software. We see Seed 1.5-VL compared against other models on benchmarks like ScreenSpot V2 and Web Voyager. Its strong scores here, especially in GUI grounding and browser use, really highlight its advanced capabilities in agent-centric tasks, meaning tasks where the AI acts like an agent to achieve goals, further underscoring its practical potential in these interactive domains. So, to wrap up our look at Seed 1.5-VL, it is clear that this model represents a significant step forward for general-purpose multimodal understanding. Its architecture, which includes a mixture of experts or MOE approach, where only parts of the model are activated for any given input, making it efficient, allows it to achieve leading performance across an impressive array of tasks, from visual puzzles to complex agent interactions, despite its relatively compact size. The model's strong reasoning and generalization are particularly noteworthy, pointing towards exciting future developments. That is all for this segment of the AI Research Roundup. Thanks for tuning in.